Um, so is it right? So Iris is a very popular data set. Okay. Iris data set, and I'll show you how to download this. I have it on my local machine, but you can also download it from internet. So just give me a second. I want to go to Google and yes. So here I'll type Iris dataset, okay? And let's go to Wikipedia to know about the dataset. So this is the sample, okay. 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 So, okay, this is different file, but just to tell you, there are four types of flowers. Okay. Wait. This is the actual Wikipedia. Okay. Now, see, these are different flowers. You see, Iris setosa. There are four different varieties of iris flower. Okay. So you have Iris setosa, you have Iris versicolor, sorry, three were types only, not four types, and Iris virginica. Okay. So this is virginica, this is versicolor, and this is setosa. So this data set has a few parameters, and based on those parameters, we are trying to predict what kind of flower it is. Okay. But we are not going into prediction part yet. So we will ignore the prediction part. We will only look at different columns that it has. So it has about 150 records. Okay. That was 150 rows. And it has 5 attributes. So sepal length, sepal width, petal length, and petal width. Right. So these are 4. And based on these 4, we are trying to predict what kind of species of flower it belongs to. Okay. So for example, yeah. Anyway, we will download it. Okay. And if you want to see, so basically, the main purpose why this data set is used is based on those 4 attributes. Can we predict which species of flower it is, right? So you measure sepal length, sepal width, petal length, and petal width. So it has those 4 metric, and based on those, we are going to predict which kind of species that it's like prediction. So if you know this 4 metric, can you predict which species it is, right? And that's how botanists would do, right? They when look at the flower, they measure those parameters and they say, oh, this flower belongs to so and so species, right? So can we say that? But again, today, as I said, we are not talking about prediction part. We'll just see how to read different data and maybe create some plots. If you want to download this data set, you can type in Google Iris dataset download. You can download it from Kaggle, you can download it from this dataset was created by UCI. Okay. So this is University of California, right? UCI. Okay. So University of California, Irvine. And okay, if you want to download it, you can download it from here. Okay. So you can download it, but I already have it. So I'm going to use it from my local drive. But as I said, you can download it from UCI website. So, okay. And download and unzip. On your machine. Let me put it as multi-line comment. This is multi-line comment. Okay. Triple quotation.
Three codes. Okay.
Okay. So now let's see how to read this data. Okay. So I'm going to import pandas as PD. I'm giving it a nickname, or I'm giving it a, they call alias, PD. PD is alias for pandas. Now let's say I want to read. So first, okay, we'll give the location, okay, file location. File location is on my local drive. So you asked me a question earlier, Shiva. Okay, I didn't want to answer in that class. Tomorrow I'm going to answer there, that class.
Yeah.
There is no difference between single quote and double quote, actually. Absolutely no difference.
Okay. Okay. Yeah.
Okay.
Because always I think from the Java angle as well. So
Ah, right. So, correct. So this is totally different. In Java C, we use single quote for single character, and multiple
correct.
characters we use double quote. But Python, there is no single quote concept in Python.
Different. Oh, okay.
There is no character or string concept. So single single character we see character like get ch.
Got it. Got it.
But
And
in
also, so Python has oops concept as well,
yeah,
right?
yeah, yeah,
So,
yes.
okay. Okay. Yeah.
So we will do it. We'll do it much later, in fact.
Sure. Because that's the challenge, right? It executes individually, not as a consolidated, right? Then that's tricky as well, right? For the resources, how it is overloading, the other stuff, which I'm thinking
Right.
now.
Uh, Trust me, Python is much simpler. It has all those concepts, but it has very simplified concepts. You will not get confused like Java.
Mm. Okay.
It has same those concepts, but it has simplified. It has very much simplified. And when we go there, you can see that you can learn Python OOPS in 2 days, where Java OOPS might take you a week to learn.
Sure, sure. Yeah. I'm like looking forward to that. Yeah. Thanks, Arpan.
No problem. So I have this in my D drive data set, and yes, here I have Iris, and it is CSV. Okay, so I'm going to copy this path and I'm going to paste it here. So here you have to paste it twice. Either you give forward slash like what you do in Mac, okay, or you give backward slash twice. Why twice? Because single backward slash, okay, it will treat it as your escape sequence, right? And you will end up having problem. So best is use forward slash like Mac. And then I have iris.csv. Okay, so when you download and unzip it, you will find iris.csv file there. Same file I am. Okay, I'm just giving the location here. Now I'm going to read it into our program. Okay, so pandas has functions using which you can read a file. Okay, you can read any file. In fact, you can read even a zip file directly by pandas. Pandas. So it has different method. So we have a method called pd.readcsv. Read CSV, you can see, read CSV, read FWF, GBQ, HDF. These are different file formats. And it can read multiple file formats, Stata, SQL, SPSS, all these things it can read. So we are going to read CSV file. So when reading CSV file, you give the path, okay, where the file is present. So I'm going to give file location path, and I'm going to say data or iris data, just to, so iris data equal to pd dot read CSV, okay, and yeah, and you want to see, you just say print iris data set, right? So when you run it, okay, it will actually it because we have multiple rows and columns, it will give you first two columns from left and last two columns. Okay, first two columns and last two columns. It can give you at max 6 columns or 5 columns. Sorry, 5 columns only. So including ID, it has got 6 columns. So it is not going to show you all. You will get first two and last two. And in rows, you'll get first 5 and last 5. Okay. There are different ways, we will see some examples on how to slice and dice here. So, okay. So now you see, this is the ID column. This is sepal length in centimeter. So you have 5.1 centimeter, 4.9, 4.6. Then you have petal width, 0.2, 0.2. You have 2.3. So if you see these two values, sepal length of Setosa and sepal length of Virginica, they are almost similar, right? Sepal length is little smaller here, but almost like 5 and 6.7, like almost like 1.5 centimeter difference. But see the petal length there's so much of difference, right? It's like almost no petal. There's no width to this petal. But here petals are quite big. So machine learning algorithms will look at these patterns, but as I said, right now we are not getting into that. Okay, so you printed the entire data set. So it will print you first 5, last 5, if it has more than 10 rows. Okay, and if it has more than 5 rows, it will give you only first 2 and last 2. Now, if you want to see only the first 5 rows, so you will say print. Okay, you have iris data dot head. Okay, head is a function that will give you first 5 rows. So now when I say first 5, see it gave us all the columns here. So you have ID, triple length, sepal width, petal width, and these are, remember yesterday we discussed about index. So index is automatically added when you read a data in data frame, pandas. If you read automatically, there's a way to drop, okay? You can say drop index, but better you keep it so that you can uniquely identify each row. So this is row 0 to row 4, and this is the complete data. Okay. So this is your head for top 5 rows. You have tail for bottom 5 rows. Okay. So if you want to print only the last 5, you can say tail. Okay. So tail will tell you bottom 5. Now you don't want 5. Let's say you want only 3. Okay, you want only 3. Then you can give 3 here. So if you do not give any value, by default, it will assume that you want 3 rows. But if you, sorry, what I'm saying, if you do not give any value, that means it assumes that you want 5 rows, correct? Whether top 5 or bottom 5. But if when you mention it, then it will give you only those number of rows. So you get only bottom 3 rows. Okay, so this is how you can get the rows. Now I want to know the size, how many rows and how many columns. Okay, so it's called shape. So print, okay, number of rows. Okay, now let me put format string. So I'm going to say number of rows is, and here you will have iris data dot shape. Okay, now shape is going to give you a tuple value with rows and columns. So if I want only rows, I will say 0 of 0. And if I say 1, it will be number of columns. So I'll say, oops, this is happening. And number of columns is, I'll make this as 1. So see, it says number of rows 150. And number of columns. So you can get number of rows and columns using shape. If you print shape, it will give you a tuple value. So I want to read indexing of tuple, right? I'm doing indexing of tuple of 0, of 1. What else we have? Let's say,
Swapnil, what is that F means
yeah.
after print?
Yes. So see, if I don't give F, okay, and then when you run it, then this will be printed as it is. You see?
Oh, it's a text. Okay, okay.
Right?
Okay.
It's a text, right? It's a quotation. So it will
Mhm.
print as it is. Now, when I put F here, so it's like indicating to Python that I'm going to use variables inside the text.
Okay, that's the convention.
Okay.
Okay.
So this is to indicate that we are going to use variables inside the text, and we'll do that in the evening today.
Sounds good. Sounds good. Thank you.
No problem. Okay. So now let's say I want to know different columns and their data types. I want to know how many columns are there and what are the data types. Okay. So how many columns we know, right? How many? Okay. What are the types? Okay. I'll say what are the types of columns. So you have something called as info. So I'm going to call this as iris data dot info. So dot info function of data frame will give you, so see here, it gives you information about the columns. So column number 0 is called ID and not null. Okay. So you have 150 values and not null count. Like all of these are non-null values. Okay. All of them have values. That's what it means. And data type is integer of 64-bit. Sepal length, sepal width, petal width are all float type. And last one is species, which is an object. Object could mean even strings. Strings is also treated as object. Okay. So it says there are 6, and these are different data types of each of those columns. Right?
So something any text is also considered as object, is it?
Yes. Yes.
Okay.
Okay. Yeah.
Sure.
So okay. So this is how you can get the information about your, and now this function does not, it only prints, okay, it does not return anything. That's why the the best thing would be, okay, that you give /n here so that you get details in the next row. Right? No, it's still printed above. Okay. So what I'll do is better in this case, I will do something like this. Okay. Or you don't even have, yeah. So now when we say, so you see data, what are different types of columns, and you have the complete information about each column. So you can see how many are numeric, how many are non-numeric, etc. Then we have something called as describe. So information is about information. Then you have something called as describe. Now, what describe does is it describes from the statistics point of view. So it will give you mean, describe. Okay, and when you run it, you see that? So it will pick only numeric columns, okay, because it cannot create statistics on object column, right? So that's why you see the species column is not included, only the numeric columns are included. So it talks about number of rows, the mean of all the values, mean is average, isn't it? Then you have standard deviation. This is standard deviation. This is minimum value because ID starts from 1 and goes up to 150. Minimum is 1, maximum is 150. And then it is about 25, 50, and 75%. Okay. So also it is important to know, okay, we haven't done this, but we'll have to do this from data analysis perspective. This talks about, okay, 4 quartile of a data. Okay. So for example, let's move on to Excel once. We'll talk about this. See, in when you talk about data, right? How many types of data generally do we have? From statistics point of view, we have 2 types of data. Okay, we have numeric.
Discrete and continuous or discrete or something.
So numeric is classified as discrete and continuous.
Got it.
Discrete and continuous. Okay, pardon my spelling. I think both of these are wrong or whatever. So you have numeric, okay, and then you have categorical data. Okay, you have numeric and you have categorical. Now, numeric is anything that you talk about in terms of number, right? So how many people are there? Okay, how many cards did you see? Okay, how much marks did you get? So these are all your numeric data, right? And then if we talk about categorical data, as the name suggests, these values are coming from a group of values. Okay, for example, okay, gender. Okay, I'm talking about what do you call this? I'm talking about data which can be put in structured format, structured data. Okay, so structured data can be numeric and categorical. So numeric, as suggest, it can take any value, but categorical, okay, it takes value from a group, right? So if we talk about gender, for example, right? Now gender value can only be male or female. You cannot have any other value, correct? Similarly, if I talk about regions, and data says you have north, south, east, and west. So if you if you're using the data in any table, you will only be using data from these groups, right? So these are called categorical data, right? So you have numeric, you have categorical in terms of structured data. Then you have something called as time series data. Okay. Now time series data, they are also numeric data, but this data is not, this data cannot be represented alone. It needs to be represented along with timeline. For example, if I tell you, let's say you run a business, I ask you, what is income from your business, right? What is your total sales, for example? Now, total sales is a number, right? But you'll ask me, you want my daily sales or my weekly sales, my monthly sales, my quarterly sales, my annual sales. So if I tell you the total revenue of a company is $5 million, question comes, is it their annual sales or is it their monthly sales? Correct? So number alone is not sufficient. You need to have timeline also associated with it. That's why it says time series. Numeric data, which is dependent on time, are called as time series data. And we perform different types of analysis. We'll do towards the end of our discussion. Last topic will be this. Then we have text data. Okay. So text data. Now text data is not structured. Okay. We generally perform what is called as NLP, natural language processing. Okay. This will be our second last topic. Okay. So data can be text, time series, okay, or numeric or categorical. And most of the data you'll handle will be numeric and categorical. Okay. Most of the data. Okay. And we will first focus on this data. How do you handle this data? How do you represent this data? How do you have different calculations from this data? We'll talk about this. And then towards the end, before we wrap up our course, we will talk about time series and text data using NLP. Right? So NLP, it could be as simple as finding a word cloud. Word cloud is, let's say, you're talking about a speech and you want to see which are the words that were stressed in that speech. So the word which is appearing maximum number of time will appear much bigger in size. Okay, that's what we call as word cloud. And something that is spoken less will be smaller and smaller. Okay, so based on the size of the word, you can guess which word is spoken maximum number of times in a speech or in a text, in a story. Then it could be complex in terms of understanding the sentiments. Now, let's say I run a business, okay, and people are talking about my product on Twitter. So I get access to all my tweets, all the tweets where customers have tagged me, right? So it's easy to get the data. So it's easy to get the data, but what is difficult here to understand the sentiment? Are they talking positive about my data or are they talking negative about my data? Right? So you can have positive or negative sentiment, or you can have positive, negative, or neutral sentiment. So positive, negative, or positive, negative, neutral, they belongs to categorical type. But based on the sentence, you want to predict. Oh, 70% people are talking positive about my product and 30% are talking negative about my product, right? So that is called a sentiment analysis. Okay. It could be as complex as performing sentiment analysis. We'll see that, okay, when we go there. Time series is, I want to make prediction about my sales. Okay. So if I want to predict sales for next 3 months, I need to have last 12 months sales data, right? Based on my last 12 months sales data, I can predict for next 3 months of sales. So here you are predicting only one factor, which is sales, but with respect to time, next month, next to next month, next to next month, right? So you are predicting based on the times. That's why we say time series data, okay? And we will see one example from time series data also. Now coming back to our main topic, which is numeric and categorical. Numeric is anything number. Categorical is when the value is from a group. Okay, it could be gender where you have male, female. It could be region where you have 4 values. It could be car company, let's say. So you'll put different car companies. Okay, so it's like when you look at the form, right? You'll see radio button or drop down button. Those are like categorical values. You can only select from the drop down. You can only select from the given options, right? So options are given. You have to select one of the given option. And numeric is okay. Now, again, as we discussed, numeric can be your discrete and continuous. What is discrete and what is continuous? Discrete values, okay, which can only take some values, specific values. Okay. So if I ask, how many people are there? So if you talk about probability, right? How many people? Okay. What is the number on the dice? Now, number of the dice, it can be 1 or 2 or 3 or 4 or 5 or 6. You cannot say 1.59. You cannot say 2.9. Correct? So discrete, how many people are there? Okay. How many times did you make call? Okay. So these are called discrete data. Okay. The data which can take any value, like weight. Now, weight of a person, okay, is difficult to measure. Temperature. Okay. So before I talk about this, I want to ask you a question. In your locality, wherever you are living, in your locality, I'm asking questions, so I'm expecting answer. Okay. So in your locality, okay, what do you think is the probability of finding someone with weight 70 kg? Did you understand the question? In your locality, if you pick someone, what is the probability that that person's weight will be 70 kg? What is the probability?
Maybe 50% probably.
Right. So probability in this case will be 0. Okay. Because nobody can be exact 70 kg in this world. Okay. So what
Oh,
we
okay,
do,
on dot. Okay.
yeah. So what we do here is, okay, we talk about continuous value. It is taking continuous. So now if your scale, if you're using a scale which does not have decimal point, correct? Then you pick someone, and weight is let's say 70 kg on the scale. But now if you add one decimal point, it will become 69.9 or 70.1, correct? So more and more decimal point you add, data will be more and more, it'll have decimal point. So what appeared as 70 kg to you without decimal point on the balance on the scale might appear as 69.92 kg when you use 2 decimal point. If you use 10 decimal
Got
point,
it.
if you use the weighing scale in which you, let's say you weigh gold, right? So in that case, your weight will be 69.25292868859 possible. So your value is changing with respect to time. So that's why you cannot have anyone with exact 70 kg. Similarly, temperature. Okay, so if your scale has only 1 point, decimal point, or no decimal point, right? Let's say you do not talk about decimal point. Then you talk about, like, say 22 degrees Celsius, 15 degrees Celsius, 5 degrees Celsius. But if you have 1 decimal point, it might be, 23.1 degrees Celsius, right? So as you increase the decimal point, the value also changes. So it shows that temperature, weight, pressure, time, these can take any number. So we call them as continuous variable, continuous numeric type. Okay, discrete is easy to understand. Continuous can be little complicated. So what we do in continuous, we take as in group. We say, okay, so when I say 70 kg, we assume that it is between 69.5 to 70.5, correct? 69.5 to 70.5 is your 70 kg. So we measure in terms of group, right? You can talk about group, or you talk about what is called as interval. Okay, you can have interval, you can have ratio 1/3. So let's say you have one cake and you want to divide into 3 parts. So instead of saying 33.33333333, it is easier to say 1/3, 1/3, 1/3, correct? So we measure generally continuous variable in terms of ratio or what did I say? Interval. Discrete data is easy to measure. Continuous, you will say interval or ratio. Okay. Coming to canonical type, you can have these kind of examples, and you can also have, let's say, grade. Now, when you talk about grade, okay, you have excellent, you have very good, you have good, you have average, you have very poor, and you have very poor, right? Let's say these are the values or possible values in the grade. So this is also categorical. But there's a difference between these two and this. Okay, here we talk about male, female. It doesn't matter whether you call male first or female first, or whether I say north first or south first. If I say male first and female second, doesn't mean that male is more powerful or whatever, right? It does order doesn't matter. Order doesn't matter. But in grade, order matters. Either you put E to VP, excellent to very poor, or you'll put very poor to excellent. Let's say you want to do the rating or rate my course. So rating can be 1 or 2 or 3 or 4 or 5. Right? It cannot be 3, 4, 1, 5, 2. Correct? So order matters here. Okay. So where order matters, we call it as ordinal. Okay. And where order doesn't matter, we say nominal. So categorical values are again nominal or ordinal. Nominal is for namesake, okay? It's no need to nominate. Name 5 fruits, okay? So you have 5 fruits. So it doesn't mean that if I say apple first, it becomes more sweeter or bigger size or more expensive. There is no connection between name and the any value, right? You can take any fruit name first. Same way with gender or region or car company, things like that. But rating, grading, okay? Now, what is difference between ordinal and discrete? Discrete also has 1, 2, 3, 4, 5. Rating also has 1, 2, 3, 4, 5. Well, what is the difference between then discrete value and the ordinal value? So see, in discrete, let's say you get 80%. Okay, 80 marks. I get 40 marks. It means that my mark is exactly half of yours. But we talk about rating. If you get 5 rating and I get 3 rating, it doesn't mean that my rating is 40% or 60% lower than yours. It means it is lower. But can we convert that into number? No. Right? Some person may rate it as 5, some person may rate it as 4, based on their judgment. There is no rule as such. Okay, that if this is the thing, then this. If this is the thing, then this. Right? So here there is no rule for the order in which you give the values. So that's the difference between discrete and your ordinal. They are different. Okay, they're not same. So these are different types of data that we talk about. Then question comes, how do we represent this data in statistics? If I'm dealing with single variable, how do I deal with it? If I'm talking about 2 variables, then how do I deal with it? If I'm talking about 10 variables, then how do I deal with it? So generally we talk about 1 to 3 variables because going beyond 3 is difficult to imagine. Okay. And I'm talking about, a couple of examples and you will get an idea, okay, what I'm talking about. So give me a second. I'll pull out one more presentation which will give us more idea about what we're talking here. We already discussed about mean median mode, right? So we don't have to get into mean median modes or standard deviation or variance. Uh, 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 um, visualization, yeah. So I'm talking about visualization. Okay, this is where those quadrant from where the discussion got away. We will talk about. So this still has. You should be able to see my presentation now, guys. Can you see visualization in analytics?
Yes.
Okay. So let's say, okay, why visualization? Why should we do visualization? Okay. Now visualization is again from your analytics perspective. Why should we perform analytics? Why should we perform visualization? So it helps us to understand complex data, right? We have large rows of data. You have 1 lakh rows of data, right? And it's not possible for any human being to go through each of those your 100K rows of data and try and make sense out of it. So creating a simple bar graph, creating a simple pie chart, or different types of graph which we will see will help us to understand those complex data. Spotting outliers and anomalies. And this is why we perform analytics. You want to see why a certain product is doing very well. A certain product is not doing very well. A certain region is doing very well. A certain region is not doing very well. Certain product at certain region is doing very well. Certain product in certain region is not doing very well. Right? So this is what we talk in terms of outliers and anomalies. So anomalies could be positive or negative. Okay, everything is selling at, let's say, 20%, and one is selling at 70%. So this 70% is an anomaly. Okay, outliers. Okay, now everything is selling at 20%. Why is this selling at 70%? You want to understand, even though this is a positive case, right? And it could be negative. Everything is selling at 70%, and you are selling one product as 20%. So you want to understand in that case why it is selling at 20%, not 70%. You'll be able to explore data, right? What is data about? What is data telling us, right? And you can use it to create story. Okay, and the main purpose of analytics is to create a story. Okay, now when you talk about data analytics, it is not about plotting one graph. It is not about plotting multiple graphs. It's about plotting multiple graphs in a format which tells a story. Related graphs. Now, before you plot, you may not know the story behind it, right? You will create multiple plots. You might create 20, 30, 40, 50, depending upon what kind of business you handle. Okay, may not be 50, but yeah, maybe 20, 30, okay? And then you see, maybe 20 graphs out of 30 is not telling you anything different. We all know what it means and what it is in alignment with what we believe our business to be. But 10 graphs are different. So can you put them in a format which tells a story, right? And when you present your analysis to your higher management, business head, they're not talking about mean, median, mode, right? They don't want standard deviation. They want to know the story. You need to tell them, okay, this is what happened. This is, This is what happened in this region because of which our sales increased and it's selling more than other regions, right? We believe that if you do this, this can improve our business, whatever. That's the story they want to hear. Okay, and for data analytics, storytelling is one of the key requirement. Okay, communication. Storytelling is basically your communication skill. Okay, and communication skill need not be like technical skills. It's more like creative communication skill. That is your storytelling ability. It should be able to help you to take an action. You plotted 30 graphs and you don't know what it means, and you are not able to take any action, then the plotting 30 graphs is waste. You rather not present anything to your management than you present those 30 graphs or even 5 graphs and say, I don't know what is happening, right? That's not, they are not there to see your graph. They are going to hear the story from you. If you're not able to, if your story is not able to help make any decision, then it's waste of presenting those graphs. And of course, collaboration across different departments, different teams. Okay, they will see what is happening. Okay, which area is lagging, leading, and you can collaborate with different teams. So these are different objectives of visualization, and choosing a chart type is very important. Okay, your job is not to distort the fact. Okay, your job is to amplify the impact or the fact, right? So, there's a famous saying, okay, if you torture the data enough, just like, when police does the torture, right? If they torture someone too much, they're going to accept any crime, isn't it? Even the person may be innocent, but if you torture too much, it will accept the crime. Same thing with the data. You can distort the data, you can torture data so much that data will say whatever you want it to say. But that's not a data science. Okay, your thesis, your hypothesis should be based on the data, not that you base your hypothesis and then you plot the data with half cooked data or incomplete data. Okay, so your objective has to be to see the data and then make your hypothesis, not vice versa. Aesthetic is important, right? The color and things like that, okay, is important, but that is not the main thing, right? So what it says is aesthetics should support your information, not overshadow it. So that, oh, people talk about your presentation graphs. Oh, wow, it looks so amazing, great graph. But what does this graph say? Nobody remembers, right? Nobody, nobody remembers what graph says, right? They forget the graph. That's not the case, okay? And the graph should be, good presentation skills are those which people remember after the presentation also, right? Your objective is to, present the business health to your management, right? So instead of they talking about your presentation skills, they're talking about your PPT making skills. They should be talking about the message that you want them to take home, correct? And it should not be overloaded with information. Don't try to put too many things in one graph. A graph should have only one information. One graph for one information. At max, you can have two information which are related, but not more than two. Never put too many things. Okay. There are techniques to do that, but we are not here to test those techniques. Okay. Sometimes, okay, these can be confusing to your audience. And there are different types of graphs, okay? And I'm going to share this PPT with you so you can actually go through it. Tons of graphs. We're not going to do all of them. Probably not, it's not possible for you to do all of them, but just to know that, okay? There are graphs like bar chart, box and whisker plot, and this is important, okay? Bar chart is important, box and whisker plot is important. We'll talk about it. Bubble chart, bullet graph, histogram is important. And very first graph that we're going to do will be histogram. So these are graphs that generally we use for comparison. Okay, you want to show the difference between two process, two values, two data, two geographies, two products, or similarities between them. So we use these graphs. Then for proportion, okay, this is bigger, this is smaller. Okay, this is 3 times bigger than this. That's called proportion. So you are showing similarity, but along with similarity, you're also talking about how similar they are, how much similar they are, how much different they are. So we use something like word cloud. Last word you see, word cloud. We discussed that, right? For NLP, we do word cloud. We have bubble chart, bubble map, etc. Show the relationship. Okay. Are X and Y related? Okay. So talking about the iris data set, do you think that petal length and petal width are related? Higher petal length, does it mean that it will have higher petal width? Okay, are they related? So that is what it will tell you. So heat map, Venn diagram, parallel coordinate plot, these are some graphs that we use to check the relationship. Then you have distribution, frequency, okay, how much spread they are. So we have bubble chart, density plot, etc. Then you have more graphs here. For comparison, you have more graphs. For proportion, you have more graphs. Pie chart is the common chart that we use for proportion. Relationship, you have more graphs. Okay. And distribution, of course, you have more graphs. Then fifth type is concepts. You want to explain some concept. So you can use brainstorming technique, flow chart, Venn diagram, illustration diagram. You want to show the geographical location. Okay, I want to see contribution of my business from US, right? Say, and you want to talk about sales contribution made by each states, let's say. So you'll draw a map of US and your color. You can have a color. You can have something else. Okay, each state can be represented different colors, indicating darker the color means higher production, lighter color means lower production. Things like that you can create. That's a location graph. Then hierarchy. Okay, which is like you have subset, superset, right? Hierarchy. You have tree diagram, tree map, circle packaging, etc. for hierarchy. Then process and methods. Then you can use it for patterns, for data over time. That is your time series data. Then to show range. Okay, range. Same thing, like production from each state is a range that you are showing. Lower the range, lighter the color. Higher the range, higher darker the color. That's a range type. So just refer them, okay, and you can that we don't have just 4 or 5 graphs. We have plenty, tons of graphs, okay, and they all have certain usage, right? The using right graph to represent right information is also important, okay. Okay, so this is what I wanted to talk about. So let's say you are marketing manager of a large telephone service provider. Let's say AT&T or any of those big service provider. And you want to analyze your customers' international call charges. So here I think I have just 200 customers data, but imagine this is 2 million customer data. Just extrapolate it. Let's say this is 2 million customer data. Okay, so you're going through this each data. Now this is one continuous data, isn't it? Now, does this tell you any information? Okay, so remember the first slide that we spoke about, data should be able to tell you a story, and also should be able to help us to make some actions, right? So what action can you take by looking at this data as a marketing manager? Probably nothing, right? You don't know what this data says, right? So this is what I said. You might have tons of data, but okay, without operating on it, without putting this in some format, okay, which is easier for you to understand or easier for you to um, uh, evaluate your business, right? So just looking at 2 million rows, 2 million data will not help you. So what we do in this case is we create histogram. What is a histogram? Histogram is like a bar graph where you show the count of values. So in this case, what I have done, I have looked at the minimum value and the maximum value. So if you see here, minimum value is 0, right? And maximum value 103, 4, 118. Yeah. This is the maximum value, right? And this is the minimum value. So what you do, okay, you create what you call as frequency groups. Okay. Now, typically, histogram should not, should not have less than 8 or more than 12. Okay. Best thing is that you can to get 10 groups, but you can go up to 8 to 12 groups is best, because more than 12 groups or more than 15 groups is very difficult to handle again. Again, you have too many data, and less than 5 groups is like having 2 less groups to perform any similarity or difference between them. So it says, histogram says best is to have about 8 to 10 or 12 number of groups. So here, okay, and the value or the range of each group has to be same. Range of each group have to be same. So if you talk about here 0 and 118, I can adjust 118 to 120. So you have values from 0 to 120. 0 to 120, if I take each group as 10, 0 to 10, 10 to 20, 20 to 30, we will have about 12 groups, which is perfect for us. So you will take 0 to 10 as one group, okay, 10 to 20 as other group, 20 to 30 as another group, so on. So remember the size, okay, the maximum to minimum value with each group has to be same. Okay, do not take more than, like here, I cannot say 0 to 51, 50 to 60, 60 to 100, 100 to 150, no. You can make it as a group of 15, so you can say 0 to 15, 15 to 30, 30 to 45, 45 to 60, or you can say 0 to 5, 5 to 10, 10 to 15, 15 to 20, or 0 to 20, 20 to 40, 40 to 60, whatever. It should be same size. It cannot be different. Okay, should be same size. And since we wanted to create 12 groups, so I think 0 to 10, 10 to 20 is best, right? Okay. Now, this is first step. First step is to find your frequency and create this frequency table. Second step is to count how many values lies between these two groups. Okay. So between 0 to 10, let's say 5 values are there. 10 to 20, let's say only 2 values are there. So you create, so this is your first group, create these classes. Second is count the number of values that falls within this range, which is within this range. And then third step is now you plot the bar graph. Okay, so if you see, this is what we have done. So from 0 to 10, we have about 60 values. 10 to 20, we have about 35 values. 20 to 30, we have about 20 values. 30 to 40, we have about 10 values. Okay, so this is what we have created. This is your histogram. Histogram, 3 steps. First, create the frequencies, then count the number of values within each group and plot a bar graph. This is a bar graph, but this bar graph is different than normal bar graph because one, here you have frequency, okay, or number of values, and here this is continuous. So if you see these bars continuous, it is a histogram. Generally in bar graph, it will not be continuous. If you talk about Apple, Apple production versus orange production. So you'll have one bar for Apple and another bar for oranges, right? So you will not have continuous like apple here, orange here. This is only in these cases. So that's how it's easy to identify that this is a histogram, not a bar graph. Okay, it looks like a bar graph, but two things on the y-axis, this is your x-axis, correct? And this is your y-axis. On the y-axis, you have the frequency or the count, and your x-axis values will be all continuous. All right. So now you tell me, is it not easy to understand your data using this graph than going through those, forget about 2 million, let's say even 200 rows. Is it not easier to understand how your data behaves in this format than that other format? So this is how you can represent complex data in a simple manner. Okay, tell me, what does it tell you? What is the story behind this? What does this tell you about your business? Of course, we are doing it to understand our business, right? So tell me, what does this tell you about your business? It's a question, guys. Make an attempt to answer. Boring, tired, done, over?
Yeah, it looks like the frequency at the top is 60 in the zero bill, right? See,
Right?
and somewhere in the 80 to 100 range, it has a frequency of 20.
Correct. So this is what you see.
Highest peak versus lowest. Yeah, you can identify which is peak, where is that low.
Correct. So this is what you see from the data. What do you understand about your business? How is this relevant to your business?
Yeah, so then I think if it is the bottom, the x-axis is the timeline. It doesn't look well,
And
right?
see, the thing is, you can do it in your own way, okay? As long as you are able to get a business sense out of it, it's good, right? And in business, there's nothing wrong, that is nothing right. You cannot say this is wrong, this is right. If you have a good, solid explanation, you are right, correct? So one way to look at this data is dividing this data into 3 parts. Okay, you see that almost like 50% of your customers, their bill value is between $0 to $30. Okay, so 50% of your customer have bill values between $0 and $50. There are very few people whose bill value is between $30 to $90. But again, you have significant amount of people whose bill value is more than $90, 30%. So this is the story about your business. 30% of your people, they use, high, they are like, high consumption of international calls. And 50% of them, they use very less, 0 to less amount. So this is story about your business. Now the last point. What action can you take from this? Remember, I said that working or doing for fun is not the thing, right? You have to take some action on this. What action can you take? Or what action can you plan to take?
So for the 50%, right? I understand, right? If they can be pushed for the long calls, can we give some offers to them or some discounts?
You want them to move from this group to this group?
Yeah.
And this will from this group to this group?
Yeah. In terms of the revenue, right? If you want to get revenue.
Yes, correct. Now
Revenue.
tell me, Shiv, tomorrow, if your telephone bill increases to 30%, what will you do as a customer? Not as a marketing manager. Of course, you're happy they're getting more revenue.
But they will panic, right? Yeah. I think you should give some discount, like for a
But
contract
if they
or.
give discount, then your bill will go down, isn't it?
Yeah.
Right. If they give
But
discount to you, your bill is going to go down, not going to go up.
correct.
They have to charge
Because I want
more
to
somehow.
sustain.
So
Yeah.
the thing is, okay, yes, and it depends upon the nature of the business, okay.
Yeah, nature, what you want to do.
My
Correct, correct.
thinking, this is my thinking, okay, and just for the sake of time only, I'm trying to move faster. So for my thinking is, it depends upon the business that you are in. Now, if you are selling iPhone, even if they increase the iPhone price by 100%, they make it double, still people will buy, right? There are people who, I'm just saying, okay, not literally, but right, there are some people who are crazy, mad about product, and you, as a business, you can command that price, isn't it? Imagine the price of a phone handset, Apple versus number two. Okay, number two could be Samsung or whatever, right? See the price difference between number one and number two. It's huge. It's huge because they are the brand, and they command that price. So if you think, okay, as an Apple, that you are making loss, you could say, oh, we are making loss, let's increase the price. And still, okay, you will have customers and you win. But if you are in a telecom service providing business, you cannot have an advantage over another. Tell me, as a service provider, how can you differentiate yourself from other? You are a Coke or Thumbs Up. How can you differentiate among yourself from another? You cannot, right? Only thing in these businesses they can do is reduce the price, right? And tomorrow, okay, if you come to know that, okay, if I switch my service provider, okay, assuming the same thing, if I switch my service provider to another company, my bill will get reduced by 20%. You will do it immediately. Yes or no? All of them are equally good, all of them are equally bad, right? It's not that, one service provider is providing service everywhere, in every place, every town, everywhere you get the network. There's okay, your network is great, so let me use that service. Okay, it's okay, I'll pay 10% more, I'm okay. But if you see, all of them are bad. So some place one will work, other will not work, other place other will work, this will not work. Correct? So there is no advantage for you to pay more to any of these companies. So these 30% people, if competitor, they know that, oh, 30% of companies A, people are spending more than $90 for international call, they will come up with a new plan, and they'll say, okay, if you are using international call, use our this thing, and your bill will come down to less than $80. 30% customer will leave you and go overnight. Imagine any business, 30% customer leaving you and going away. Right? One new announcement by another company and gone. You lose 30% of your customer. Isn't it? So that's why if you see, when you recharge your mobile phone, they'll have tens of options because they want to capture every kind of customer. Somebody who is heavy user, somebody who is less user, somebody who's a temporary user, somebody who loves to only use internet, somebody who loves to do something, only calls. So they have planned for everybody because they think everybody is a customer and they try to capture everybody. So as a marketing manager, you have to do something about this 30%. You have to come up with maybe new plan for this 30% so that they can reduce their bill. Okay. So maybe, in this case, okay, your objective may be the other way. You want to move these guys. As you said, you want to give discount. If you give discount, then they will come down to this side, isn't it? They'll not go to the right side. So you have to give discount so that they come to the left side. And they are at risk because tomorrow, they might leave you and go if they find a better opportunity. Right? And these are the reasons why we choose a service provider. Okay, I want to make more calls to India. Which service provider giving me least call rates to India? And every Indian will go to that provider because your main objective is to call to India. Somebody whose main objective is to use internet, they might pick another service provider which is giving least or cheapest internet internet package. If you are a retailer, okay, you say, oh, 50% of my customer are only spending $30 with me. Can I give them like buy one, get two free, something like that? So for them, you want them to buy more from you. So maybe somebody's coming to you to buy only grocery, but they're not buying, let's say, fruits. They're not buying, let's say, daily use items, shampoos and things like that. Then you say, okay, how can I make them buy shampoos? You give them some discount so that they start buying shampoos also. So in that case, you want to push them to right side. You want them to spend more with you. But telecom service provider, your objective will be that they spend less with you. So your action, your decision will vary based on the business domain that you are in. Okay, so this is just one type of analysis, and this is how we learn histogram. Then we spoke about what is the time? Okay, maybe 5 more minutes and we'll wrap up. Okay, types of data, you have discrete, continuous, you have interval and ratio, canonical, you have ordinal, nominal. Nominal can be again no ranking. You can have multiple values like regions, 4 values, right? Or car makers, you might have 4, 5 regions. Binary is 2. Okay, like yes, no, male, female. Okay, so when you have just 2 options, we call them as binary, and more than 2, we say nominal. Binary is also nominal, but binary is a special case of nominal. Then you can have visualization based on univariate. Okay, so univariate, uni means one, variate means variable. One variable, you're dealing with one variable. Histogram that we did was an example of one variable. We had only one variable, telephone bill usage, right? Telephone bills. So telephone bill is only one. So the graph that we drew is based on just one variable. So we call it as univariate. Then bivariate, we talk about 2 variables. Okay, so we'll talk about scatter plot tomorrow, which will be 2 variables. How do you represent 2 variables? Then you can have 3 variables. So in this case, you see, you have company size on x-axis, revenue on y-axis. So here you have company size. Company size could be like small, medium, large, extra large, whatever, right? So revenue less, more, high. And then you have age of the company. How old is the company? So this company is bigger in size, older in establishment, and also had higher revenue. So typically, it is difficult to go beyond trivariate in our 2-dimensional thing. So we'll stop our analysis at 3 variables at a time. Okay. So you can talk about 1 variable, 2 variables, and at max 3 variables. So we'll see different types of plots that we can use. Okay, so this is another example. We'll talk about tomorrow. Okay. Any question before we end this? So tomorrow we'll talk about different plots, different graphs, and then we'll come back to our pandas again. All right.
Sure, Satyan. Thank you.
Thank you, guys. Thanks, Shiv. Thank you, guys. Take care. We'll see you tomorrow, same time. Bye.
Thank you. Bye for now. Bye.